Hello friends, in the last previous video we have seen that comparison test of the first kind and comparison test in the limit form. In the limit form we have seen that when one series is a convergent, the other series is also convergent. When one series is a divergent, other series is also divergent. Now here we discuss about comparison test of the second kind. Now I am going to write if summation un and summation vn are two positive term series and there exists a positive integer, there exists a positive integer m such that un divided by un plus 1 is greater than equal to vn divided by vn plus 1 for all n greater than equal to m. Then number 1, first condition, then summation un, first series summation un is convergent if summation vn is convergent and second condition is if summation vn here is divergent if summation un is divergent. So this is the comparison test of second kind, statement of the second kind. See the relation between the terms of the sequence un divided by un plus 1 greater than equal to vn divided by vn plus 1. So friend, as usual we consider the sequence of partial sum. So let Sn equal to u1 plus u2 plus un and Tn equal to v1 plus v2 plus vn be the sequences of positive term series, sequences of partial sum, sequences of partial sums of summation un and summation vn respectively. So we have taken these are the two sequences of partial sum. Now we can see that here it is given for all n greater than equal to m, the relation between two series, that is if we take here we write this um divided by un equal to um divided by um plus 1 into um plus 1 divided by um plus 2 into um plus 2 divided by um plus 3 dot like this, un minus 1 divided by un. Now um divided by um plus 1, this term is greater than Vm divided by Vm plus 1. This one is greater than Vm plus 1 divided by Vm plus 2. This term is greater than Vm plus 2 divided by Vm plus 3. Likewise, this is greater than Vn minus 1 divided by Vn. So the sum total product of the below term is smaller than the upper term. Now but this is equal to, you can see that the lower term is equal to Vm divided by Vn. Then what we get here? We can see that we have um divided by un is greater than or equal to Vm divided by Vn. Now from this let us write here, this is equal to transferring this Vn to this side and this un to this side, we get here Vn into um divided by Vm is greater than equal to un. Um is a fixed term, Vm is a fixed term, so its division is also fixed. So it is like suppose k, then we get what type of relation? Un is less than equal to k into Vn. So we arrive at the comparison test of the first kind, and hence we can apply the comparison test of the first kind, which is known to u. So this shows that whenever Vn is a convergent, un is also convergent, and when un is divergent, Vn is also divergent. By comparison test first, what is the comparison test? Summation un is convergent whenever if summation Vn is convergent, which is the first point of this series. And what is second type? Summation Vn is a divergent whenever summation summation un is a divergent, which is the second form, second condition, second part of this comparison test. Now we see how we can apply this comparison test to prove the examples. So let me take clear some part of this. Okay, so let us see. We see some examples show that the series 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus is convergent. So friend, we know that to prove this example we apply the comparison test. Now you can see that here what is 1 divided by 2 factorial? Here 2 factorial is equal to 2. So 1 divided by 2 factorial equal to 1 by 2. Now 3 factorial equal to 2 into 3, and 2 into 3 is a 6, and 6 is greater than 4. So from this here therefore 1 by 6 is less than 1 divided by 4. Then 1 by 6 is less than, therefore we can write this as 1 divided by 3 factorial is less than 1 divided by 2 square. Again 4 factorial 2 into 3 into 4, that is this is 6 into 4, this is equal to 24, and 24 is greater than 8. 24 is greater than 8. This shows that 1 divided by 24 is less than 1 divided by 8. But what is 1 divided by 24? That means 1 divided by 4 factorial is less than 1 divided by 2 raised to 3. Then you can see that here whenever we have 3, this term is less than 1 divided by 2 square. Whenever we have 4, this is less than 1 divided by 2 raised to 3. So similarly here 1 divided by n factorial is less than 1 divided by 2 raised to n minus 1. Then here we have this series 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus 1 divided by 4 factorial plus. Now 1 plus 1 divided by 2 plus 1 divided by 2 square plus 1 divided by 2 cube. If we take here 1 divided by n factorial plus here plus 1 divided by 2 raised to n minus 1 plus like this. So every term of this below series is greater than the previous one, and hence we get that this is a greater series. And we know that this is a geometric series 1 plus 1 by 2 plus 1 by 2 square plus 1 by 3 2 raised to 3, and this geometric series is a convergent series for r is less than 1. Here common difference is 1 by 2 and 1 by 2 is less than 1. So geometric series is a convergent series, and therefore this geometry by comparison test, this is like summation un is less than summation vn, and summation vn is a convergent, therefore summation un is also convergent. Hence the given series, that is 1 divided by 2 factorial plus 1 divided by 3 factorial plus is a convergent series. Now let us see another example. Here you can see that this is a very useful test, and by using that test we can easily show that where the given, or we can easily check that whether the series is a convergent or divergent. Show that, let me write the example. Show that the series 1 divided by log 2 raised to p plus 1 divided by log 3 raised to p plus 1 divided by log n raised to p plus diverges for p greater than 0. This is a divergent series for p greater than 0. Now we know that very important limit form, since we can see that log of n raised to p divided by n as limit n tends to infinity, this is equal to 0. Since friend we know that log of 2 and log of 100 is equal to 2, log of 1000 is equal to 3, log of 1000 is equal to 3, and therefore if we take log of 100 here log of 100 divided by 100, log of 100 divided by 100, so that will be 2 divided by 100, and 2 divided by 100 is a fractional term, that is 0.02. Similarly log of 3, log of 1000 divided by 1000, that is 3, so this will be log of 1000 divided by 1000, and this is equal to 3 divided by 1000, and this is equal to 0.003, and here this term is 0.02 and here 0.003. so that means this fraction is a decreasing fraction, so that whatever if p is a greater than 0, then this definitely will tends to 0. So this means this denominator is a greater than numerator, hence log of n whole raised to p is a smaller than n. If it is smaller, denominator is greater than numerator, they are reciprocal. If we take log of n whole raised to p is greater than 1 divided by n. and hence this term log divided by log of 2 raised to p plus 1 divided by log of 3 raised to p plus 1 divided by log of n raised to p plus, then this is a greater than, this term is greater than here 1 divided by 2 plus 1 divided by 3 plus 1 divided by n plus, and this series is nothing but 1 divided by n, where if we compare this, the series 1 divided by n raised to p, we have seen that this series is converges for p less than 1, p greater than 1, and diverges for p less than or equal to 1. Here p is equal to 1, and hence this series is convergent. So the given series is greater than the divergent series. Now we can apply the comparison test whenever un is less than equal to k into vn, and when un is divergent, summation vn is also divergent. Here the relation is like this: summation un is less than equal to kn. This is my un and this is a vn. So you can see that un is less than equal to k into vn, and here un, this one is a divergent series, and obviously vn is divergent, so that means this log series is a divergent series. Now let us see another example. Show that the series 1 divided by 3 square into 2 divided by 4 square plus 3 divided by 5 square plus into 4 divided by 6 square plus 5 divided by 7 square into 6 divided by 8 square plus is convergent. Now here you can see that here if we write it in terms of u, where we have this un equal to, if we take it as a 2n minus 1, then this is a 2n. These are all even terms. So this is 2n, and here this is a 2n plus 1 whole square, and this is equal to 2n plus 2 whole square, right? So this is un. Now this is my un. Let us take vn equal to 1 divided by n square. Let us take limit of un divided by vn. Un divided by vn, 2n minus 1 into 2n divided by 2n plus 1 into whole square into 2n plus 2 whole square into 1 divided by n square. So this will be n square. Now this is equal to you can take here we take we divide numerator and denominator by n raised to 4. That means 2n minus 1 divided by n into 2n divided by n into n square divided by n square. How many n's? We have taken 4 n's. Now here 2n plus 1 whole square divided by n square into 2n plus 2 whole square divided by n square. So n raised to 4. So this will be you can see that this is equal to, we can write this as a 2 minus 1 by n into 2 into 1. Here we get the n square get cancel. Now in the denominator this will be 2 plus 1 divided by n whole square, and here 2 plus 2 divided by n square, 2 divided by n whole square. Now let us take the limit of this, limit of un divided by vn equal to limit of this term, limit. So let us apply limit 2 minus 1 by n into 2 into 1 divided by 2 plus 1 by n whole square into 2 plus 2 by n whole square as n tends to infinity. As n tends to infinity, this will be 0, this will be 0 and this will be 0, and we get 2 into 2 divided by 2 square into 2 square. This 2 into 2 and 2 squares, we get 1 divided by 4. 1 divided by 4 is less than 1. Now we can apply the limit form. We have seen that whenever un divided by vn in the limiting case is equal to L, and when L is less than equal to 1, the series is a convergent series. So here the behavior of the series is alike. That means whenever one is convergent, other is also convergent. When one is divergent, other is also divergent. Here 1 divided by n square is a convergent series, as by this comparison with n raised to p. So this will be converges for p greater than 1. Here if we compare this series with 1 divided by this n raised to p, here p2 is greater than 1. So this series is a convergent, summation vn is a convergent, and hence summation un is also convergent. Now let us take one more example of this comparison test, and this is a very used one. We have seen the limit of this trigonometric series. We familiar with the trigonometrical formulas. So here we take one series of this trigonometric form, investigate the behavior of the series whose nth term is sine 1 by n. Okay, so what it is given here, un is equal to sine 1 by n, and we consider Vn equal to 1 by n. So if we take limit of un divided by Vn, this is equal to limit of sine 1 by n divided by 1 by n, as n tends to infinity, this is equal to 1, and therefore summation this series here L is equal to 1 and it is less than equal to 1. So this series behave alike. One series convergent, another is convergent, as limit L is a finite, and hence here we know that summation 1 divided by n is a divergent. As this series is a divergent series, this summation un, that means summation sine of 1 by n, is also divergent series. Now let us see one more example of for the comparison test. Let me clear this part first. Friends, I hope you are enjoying and you are getting the knowledge of the comparison test. Here we have seen the examples of the comparison test, and we are here we discuss about one more example test the convergence of the series whose nth term is n cube plus 1 whole raised to 1 by 3 minus n. This is the nth term of the series. So first let us write un is equal to n cube plus 1 whole raised to 1 by 3 minus n. Now taking n common from these both terms, so n common, this will be 1 plus 1 by n cube whole raised to 1 by 3 minus 1. Now let us expand this by binomial theorem. Then we get that this will be 1 plus 1 divided by 3n cube plus infinite terms minus 1. Here plus 1 and minus 1 will be cancelled and we get n into here 1 divided by 3n cube plus. Now ignoring the remaining terms of these part, we get here 1 divided by 3n square. Now easily we can take here let Vn equal to 1 divided by n square. Vn divided n square, then we can see that Un divided by Vn equal to 1 divided by 3n square into n square. N square get cancel and we get 1 by 3. So here limit of Un divided by Vn is equal to 1 by 3, which is less than 1, and here the series behave alike. As series behave alike, then the one series convergent, another is also convergent, and we've seen that the summation Vn summation 1 divided by n square is convergent. As summation 1 divided by n square is a convergent, summation Un is also convergent, and hence the given series is a convergent series. Now we see the last example on this test and we stop. The example here, test the convergence of the series summation 1 divided by n raised to 1 plus 1 by n. So let me write first the nth term of this series. So this will be n raised 1 divided by n raised to 1 plus 1 divided by n. So this will be 1 by n into n raised to 1 by n. Now we take Vn is equal to 1 by n. Then we can see that Un divided by Vn is equal to 1 by n into 1 divided by n raised to 1 by n into here n Vn. So this n get cancel and we get 1 divided by n raised to 1 by n. Now if we take the limit of this, limit Un divided by Vn, as n tends to infinity, limit of n raised to 1 by n, and this will be so this is a 0 and this we get here 1, and you can see that the two series behave alike, summation Vn and summation Vn behave alike, and therefore here summation Vn, that means 1 divided by n, is divergent. This series is a divergent series, and therefore summation Un, that means 1 divided by n raised to 1 plus 1 by n, is also divergent. Here this series is a divergent. So friends, here we have seen comparison test of the second kind and a few examples regarding the comparison test. I hope you have enjoyed this. Thank you for